All right, welcome back. We're starting Unit 2 today. We're going to be taking a look at the atom. So let's get that projected. All right, so going up top here for a new unit, new section in the notebook here, unit number 2. A lot of people like this. This is one of people's favorite units throughout the year. The atom. All right, and we're going to start 2.1 here today with atoms, isotopes, and ions. Those are the topics we'll cover here today. So I'm going to start by drawing an atom as best as I can, which is not very good. So I've got these P positives in the circle and N zeros. Those are all kind of in the middle there. We're going to call this middle area the nucleus. So the nucleus contains the protons and the neutrons. So P positives and N zeros. We'll talk about those in just a minute. Around the outside, then, we're going to have a couple of electrons, and they're kind of flying around, kind of in a circle. Not really. We'll discuss that later, but for right now, we're just going to call it a circle. And this is an electron orbital. So our rough picture of what an atom looks like here. Those P positives, and you'll see me abbreviated as P positive a lot. These are protons. They have a +1 charge. They have 1 atomic mass unit, which is a unit of mass, obviously. Very, very small. It's like one, gazillions and gazillions of a gram. You think about how small atoms are, and this is just a small part of an atom. So very, very small. That's probably the only time you'll ever have to write atomic mass unit, because we're usually just going to put AMU. You guys are welcome to just use AMU and just know that stands for atomic mass unit. And protons are found, as in our picture, in the nucleus. Next up, those N zeros are neutrons. And the reason why they're N to the 0 is because they have 0 charge. So they don't have any charge, kind of the term neutral for neutrons. They do have 1 AMU, so they do have the same mass as a proton, and they are also found in the nucleus. All right, next up, everybody's favorite, flying around the outside, are the electrons. The reason why they're E negative is because they have a -1 charge. For this class, we're going to claim they have 0 AMU. Now, when you guys take physics next year in 2 years, you'll probably learn that electrons do have a mass. It's just much, much smaller than the mass of a proton or a neutron. So for this class, for chemistry, we're going to kind of negate that charge, and we're going to say that it is 0 mass. And these guys are found in electron. So there's that E negative abbreviation in electron orbitals, which we'll spend a whole chapter talking about in a couple of weeks. All right, so there we go. There's our atom, kind of a diagram of it, with the nucleus, the protons and the neutrons in the nucleus, and the negatively charged electrons zooming around on the outside. All right, next up, for those of you who were in class, I handed out a gift. It was periodic table day, and everybody received a periodic table with compliments of me. For those of you who aren't here, you can print one. I've got them on Canvas, so please do print one. You're going to need them. When you return to school, I've got one for you as well. Very important tool. I often say if I'm taking a chemistry test and I have the option of only a calculator or only a periodic table, I would choose the periodic table every single time. Now you'll never have you'll never have that particular option, that those options presented to you. You'll always have a calculator and a periodic table, but that's how important of a tool this is. You're going to need it, put it somewhere safe. You're going to need it for pretty much every homework for the rest of the year. Wherever you do that homework, whether it be at home or study hall, you'll need access to that periodic table, so put it somewhere safe. On the periodic table, then, we're going to take a look at some of the things you'll find. So this is what one square looks like. In fact, here is that square. So the 2 He, helium 4.002262. So starting off right here, this is what we call the atomic number. And we symbolize it as Z. It also has a different meaning. It's also the count of protons. So that 2 tells us that all helium have 2 protons. All right, next up, the He, this is the atomic symbol. Very, very important. You guys notice, and again, you have hopefully your own periodic table, or will shortly. You guys notice there's a lot of 1-letter and some 2-letter abbreviations. Shouldn't be any 3-letter abbreviations or 4-letter abbreviations. Chemists like to use shorthand a lot, and you guys are welcome to do the same. Kind of quickens things up when you just use the 1-letter or 2-letter abbreviations of elements. Here's the thing, though. You have to use them correctly. This right here is cobalt. This right here is carbon monoxide, completely different than cobalt. So when you use these, you have to use 1 capital and then 1 lowercase letter if there are 2 letters. I see it a lot like this. This is sodium, and a lot of people like to write sodium. Okay, the N is larger than the A, but they're both capital. This will not work. This will not work for cobalt. If you're going to use the shorthand, you have to use it appropriately, and they will lose points if you're giving me 2 capital letters, or I've seen this as well. Big NA. Well, no, that's a lowercase n and a lowercase a. The N is just really, really large. It doesn't make it capital. Not appropriate. This is sodium. This is how it needs to be written. Capital N, lowercase a. If you're not going to do that, if you only write in caps or only write in lowercase, just write the whole name. Write the word sodium. You can't use the shortcut if you're not going to use it correctly. Back to our periodic table then. The number on the bottom with all the decimal points, that's the atomic mass. And that is an average mass. So in a few moments here, we're going to get to the mass number, which is different than the atomic mass. We're going to spend all next week talking about the atomic mass, which again is an average of all the atoms in the universe. And that makes it a little bit different than just the mass of 1 atom. So we'll talk about that more later. Just I want you to know for right now, it is an average. All right, so we kind of mentioned it before. The number of protons, that's your atomic number, that defines the element. So what we mean by that, everything that has 1 proton is, we can use our periodic table for this, 1 proton would be atomic number 1. Everything that has 1 proton is hydrogen. Everything that has 8 protons is Again, you can take a look at your periodic table. You just need to find number 8. So they go left to right. So left to right, and then down a row, 3, 4, 5, 6, 7, 8. Oxygen. There's number 8. So everything that has 8 protons is oxygen, and all oxygen have 8 protons. I'm going to turn the page. We've got a little bit of room left here, but I want a little more room for the next note here. So I'm going to go and turn the page. Jump back up to the top. So next up, we're taking a look at isotopes. So atoms of the same element. What does that tell us right there? That tells us atoms that all have the same number of protons. If you have the same element, you have the same protons. They can, though, have different numbers of neutrons. There's our symbol for neutron, the N0. These are called isotopes. So we're going to take a quick look. We're going to diagram some of the common isotopes of hydrogen. So common isotopes of hydrogen. First off, we have one that has 1 proton. I'm going to draw the electron just kind of up here. 1 proton, 1 electron. This is it. This is a common isotope of hydrogen. We call this one hydrogen. The symbol is 1, 1, H. Like that right there. 1 on top, 1 on bottom, H. So there's hydrogen. Very, very common hydrogen. All right. Let's draw another isotope. So you notice how this one has 0 neutrons and this one has 1 neutron. They both have 1 proton because they're both hydrogen. The symbol for this one is 2/1 hydrogen, and its name is deuterium. Deut for 2. A third common isotope of hydrogen, again, just 1 proton. These are all going to be hydrogen, and that's defined by the 1 proton. But this one is going to have 2 neutrons. Again, 1 electron. We'll talk about that in just a second. This one is hydrogen 3, also called tritium. Now, don't worry about isotope names. It's not something I'd ask you. I've got them here so you guys can see it, but not something I'd test you on. All right, so taking a quick look at these symbols, 1 proton and 0 neutrons has just the 1 there. 1 proton and 1 neutron has the 2. 1 proton and 2 neutrons has the 3. So hopefully you're kind of recognizing the pattern and why the pattern is as it is. Excuse me. So next we're going to take a look at, sorry, get off the page there. Next we're going to take a look at what we call isotope notation. Now this big X, this is representing an atomic symbol. Now if you look at your periodic table, there is no just element X. There's an XE for xenon, but there's no just element X. It's because we're using it like a variable in math, and we can use any symbol we want. Like up here, we used H. So any symbol you want can fit in here. And kind of up in that top left corner above it, we're going to put A. A is what we call the mass number. And the way that we find the mass number is we add the number of protons and the number of neutrons. And again, you saw that up here, just 1 proton, 0 neutrons, a mass number of 1. One proton and one neutron has a mass number of 2. One proton, 2 neutrons has a mass number of 3. So protons plus neutrons equals A. You sometimes, not always, are going to see the Z down here. You don't always see that though. The reason why, we already know what Z is. We took a note on it on that last page. This is the atomic number. And we don't necessarily have to have it, because if you have that symbol with your periodic table, all you need is the H, and you should be able to figure out that it is atomic number 1. Its Z is 1. So more often than not, you will just see isotope notation written like this. Or here's your element symbol with just the mass number and not the atomic number. Every once in a while, you're also going to see it written like this. The atomic symbol and then a line and the number. So for instance, I think I mentioned H1 or H2 or H3. Sometimes you see it like that. So H-1 would be hydrogen 1. Okay, you're going to have quite a few problems like this on tests, on homeworks, on quizzes. You need to figure out how many protons, neutrons, and electrons this atom has. They didn't give us the Z. It's always easy when they do. When you have the Z there, you can just call it protons. They didn't give it to us, so we'll need our periodic table. We need to find element C. Its atomic number is 6, and that means it has 6 protons. For the neutrons, we need to do a little bit of math. We know that A, that's this number here, is equal to protons plus neutrons. We have 6 protons. We have an A of 13. 13 minus 6 will give us our neutrons. Excuse me, that's something we can do in our head. There are 7 neutrons in this atom of carbon. This is not work I require you to show. If you can do this mathematically in your head, I'm always good with that for these particular problems. If you need to do this, that's fine. We're going to have some bigger numbers. If you have to set it aside, do the math, that's perfectly all right. For right now, and this is going to be the next thing we change, but for right now, our electrons equal our protons. So there we go. There's carbon 13. It has 6 protons because all carbon have 6 protons, 7 neutrons because its mass number is 13, and 6 plus 7 is 13, and 6 electrons because it's an atom of carbon. And I have a little bit of room down here, but I'm going to go ahead and flip the page. This is our next subject. I'm going to keep it all together. For all atoms, the number of protons is equal to the number of electrons. And that's for all atoms. It doesn't mean protons always equal electrons. They're just not atoms when they do. When you have more or less electrons than protons, it is called an ion. And we do have 2 different types of ions, depending upon whether you have more electrons or less electrons. First type is called a cation. These are positively charged because they have more protons than electrons, more overall positive charges than negative charges. And the opposite of cations are anions. These are negatively charged because they have more negatively charged electrons than protons. Go back to our image of hydrogen here. So one proton, one electron. This is an atom of hydrogen. Now I'm using hydrogen because he's kind of a special atom. He can do both. Here we're going to have him gain an electron. And sometimes hydrogen does this. So hydrogen atom has one proton, one electron, equal numbers. Now we have two electrons and one proton, not equal numbers. This is what we call the hydride anion. More electrons, two of them, than protons, just one. And we have special symbols for this. So back to that hydrogen atom, where we had equal numbers of positives and negatives, we would just write H1, no charge whatsoever. The positives and negatives cancel out, so no charge. Over here, because we have one more negative charge, the overall species is negatively charged. So I put a -1. Here's our hydrogen, -1. As I was mentioning earlier, hydrogen is kind of a special atom because he can gain an electron, become hydride, or he can lose an electron. So no electrons on this one, and this one would be a hydrogen cation. So here's your cations. They are positively charged. There's more protons than electrons. So again, one proton, no electrons. And the way that we write that is H+1. And there's the 1 telling us there's no neutrons, just one proton. And the +1 telling us there's one more electron, one more proton than electron. Again, when you don't have a charge at all, that means you have an atom and you have equal numbers of protons and electrons. Couple of quick examples, like what you might see here shortly on your homework. So there's Cl, a mass number of 36, and a charge of -1. Protons, neutrons, electrons. Hey, I don't know off the top of my head. It's not a requirement to memorize the periodic table. You're going to get one on every single test. I just need to be able to find it. There's Cl. My number of protons is 17. That's my atomic number. So that part was easy. I have 17 protons. To figure out my number of neutrons, I'm going to say my A, which is 36, is equal to my number of protons and my number of neutrons. I have a 36 here. I know that there's 17 protons. I'm working with chlorine. There have to be 17 protons. So the difference between 17 and 36 is my number of neutrons, and that is 19. Finally, to get my electrons, you can say, well, we have one more negative charge than positive charge. If you prefer to see that negative, or mathematically, excuse me, the charge is equal to protons minus electrons. So we have a -1 overall charge, and we have 17 protons. So 17 minus what gives us -1. And a lot of times I'll just kind of look at it and say, I need one more negative charge than positive charge. If I have 17, I'm going to need 18 negatives. So I have a leftover -1 charge. Take a look at one more example here. So this one is a cation. It's got that positive charge. So again, a lot of homework problems like this. How do you find the protons, neutrons, and electrons? Well, we need a periodic table. We need to find Na. Haha, there it is. Na, there's our sodium. He has 11 protons. Now to figure out how many neutrons, remember, we know that A is equal to our protons and our neutrons. We have an A of 23 and we have 11 protons. So we must have 12 neutrons. 12 plus 11 is 23. Now we get down to electrons. Again, what this is telling us is that we have one more positive charge than negative charge. Again, if you want to see it mathematically, (11 minus what gives us positive 1? Well, 11 minus 10 is going to give us that. Again, I usually don't do the math for the electrons, and you don't have to do any of the math as long as you're getting it right. I just look at it and I say there's 11 protons. We have one more positive than negative. So one more positive than negative. I've got 11 protons and 10 electrons. All right, so you guys do have a homework here over the weekend. That concludes these notes, your first notes. I think these are the longest notes. I hope these are the longest notes of this unit. So take a look at that homework. It goes really nicely with these notes, and hopefully the examples helped. Have a great weekend, and I'll see you guys later.